In the previous video, we took a look at some of the concepts and ideas behind router on a stick. And in this video and hands-on lab, we'll put together a plan, we'll implement router on a stick, and then we'll verify that it works. So here's our plan. For VLAN 1, we want to use the IP address of 10.16.8 with a 24-bit mask. And on VLAN 2, we're going to use the IP address spacing of 10.16.9.0 with a 24-bit mask. And then up here on port 0/1 that's connecting to PC1, we'll put that port 0/1 associated as an access port in VLAN 1 if it isn't already, and we'll make sure that port 0/2 is set up as an access port in VLAN 2. That's what puts PC1 in VLAN 1 and PC2 in VLAN 2. And then on the router 1/0, instead of using the physical interface with its IP address right there, instead we're going to create two sub-interfaces, a .1 and a .2. And we'll have gig 1/0.1 support the VLAN 1 traffic, and we'll have gig 1/0.2 support the VLAN 2 traffic. And the way it does that is the router looks at all inbound frames that are coming in, and it looks to see whether or not there's a tag that indicates which VLAN it belongs to. So in the case of gig 1/0.2, if the switch sends a frame and tags it with an 802.1q tag of 2, when that frame comes in the interface, R2 is logically going to have this sub-interface that's supporting VLAN 2 process and work with that frame of data that just came in. Also, to make this all work, we need to train the switch on this port that it is a trunk port so that it will add the appropriate tags as it forwards traffic over to router 2. So that is our plan of attack for setting up the router on a stick with the two logical sub-interfaces to support VLAN 1 and VLAN 2. So without further ado, let's jump in the hands-on lab and implement it and then verify that it's working. So here on our administration machine, which is DCNUG, let's go ahead and open up MT Putty. And on the left, I've got links for the Nevada router and also the Nevada switch, and then a couple of PCs. PC1 is in VLAN 1 and PC2 is in VLAN 2. Good to go. And let's begin our work at the Nevada switch. It's always a good idea to see what we have in place before we start configuring. So let's do a show VLAN brief just to verify what we have. All right, so we have port gig 0/2 on the switch associated with VLAN 2, and that's where PC2 is, and gig 0/1 is configured as being in VLAN 1, which is where PC1 is connected. So that part looks great. But what we need to do is we need to take this interface, gig 3/3, and we need to tell it that it's a trunk because it needs to include the tags as it communicates frames over to R2. So to do that, we'll go into configuration mode. And whenever you need a refresher on layer 2 and trunking and so forth, please feel free to take a look at those specific skills here at CBT Nuggets. So we'll go into interface gig 3/3, and we'll say switch port trunk encapsulation .1q, because that's what we're primarily using these days on Ethernet. And we'll also specify switch port mode trunk to tell it to be a trunk. And then we'll type end, and we'll do a show interfaces trunk. Press enter. And we have a trunk here on gig 3/3. That's great. So it's 802.1q, great, trunking. The native VLAN is 1. So as a reminder, if there's traffic for the native VLAN, in this case VLAN 1, it won't bother sending a tag. So if there's a frame that's sent without a tag, the other side implies or infers rather that, oh, this is for VLAN 1. And here it says as far as VLANs that are actually doing forwarding is none, and that's just because we need to wait a minute for spanning tree to converge. And we'll hit the up arrow key, do a show interface trunk, and I didn't give it quite enough time, but we'll give it a moment more and hit the up arrow key, and that looks better. Great. All right, so spanning tree is converged. We're forwarding for VLANs 1 and 2 on this trunk on port gig 3/3. So if we peek at our topology, this is now trunking on 3/3 over to the router. Next, let's go create the two logical sub-interfaces to support VLAN 1 and VLAN 2. So we'll pop over to the router, and on the router we'll clear the screen a little bit by pressing enter. Then we'll do a show IP interface brief to see what we're starting with, which is always a good idea. And here on interface gig 1/2, it's got an IP address of 10.16.8.6. Now, there is more than one way to set up router on a stick. One way is we could just leave the primary IP address for VLAN 1 on the physical interface and create sub-interfaces for the additional VLANs. And then any frames that come into the router on that interface, if they're not tagged, it'll assume, oh, it's for the major interface, and it'll just work. So we could leave that IP address there on the major interface and create one sub-interface for VLAN 2, or we could specify two subinterfaces, one for each of the VLANs. So currently on that interface, gig 1/0, we've got the IP address 10.16.8.6. Now, I want to share with you a couple of options regarding setting up router on a stick. So that way, no matter how you come across it or how you want to implement it, you'll be aware of both options. And that is this. So this is R2. And then we have the physical interface gig, and it's 1/0. Then we have the switch, which we just configured a moment ago on port 3/3 to do trunking out this way. For the native VLAN, if there's traffic on the native VLAN, there's going to be no tag. It looks like just a frame that's going over an Ethernet switch without a tag. And so when the router receives that with no tag, it can either do one of two things. It can process it on the major interface with whatever IP address is there and just run it. Or we could create a subinterface that tells it that it's looking for VLAN 1. And then when that frame comes in without a tag, it would logically hand it down to the gig 1/0.1 interface and process it there. So long story short, for the native VLAN, you can leave the IP address on the parent interface and just do additional VLANs with subinterfaces, or you can do them all with subinterfaces. So in our example, we're going to create subinterfaces, which means we're going to take this IP address off of this major parent interface, and we'll assign it to the newly created subinterface, which we'll make right now. So let's go into configuration mode, interface gig 1/0, and we're going to take off the IP address. We do that with no IP address, press enter, and now that IP address is removed from gig 1/0. Then let's create a new subinterface. We'll do interface gig 1/0, that's the parent, and let's use .1 for our first subinterface. Enter. Then we need to specify for this subinterface that it should be paying attention to a specific VLAN. And to use that, we're going to use the command encapsulation .1q space, and then we're going to put in the VLAN number. So in our case, we want this subinterface to pay attention to VLAN 1, which effectively is not going to have any tags at all because it's the native VLAN. So I'm going to add on top of that the keyword native, just to help reinforce the idea that any frames that come in on gig 1/0 and they don't have a tag, they should be handed to this subinterface. And we'll press enter, and then we'll give it an IP address for VLAN 1, which is going to be IP space address, and then the IP address for VLAN 1, which was, if we scroll up just a little bit, it is right here. So we'll just click and drag across that to copy it, scroll back down, paste it in, and then put a 24-bit mask on it. And then we'll do the same thing for subinterface .2. So we'll hit the up arrow key a few times, create the interface gig 1/0.2 for VLAN 2. We'll hit the up arrow key a few times, use the encapsulation .1q command, except this time we're going to tell it to pay attention on this subinterface for any tags related to VLAN 2, just like that, with the number 2. And then we'll give it an IP address. So we'll hit the up arrow key a few times, and this subnet is 10.16.9. So this subinterface will get the IP address 10.16.9.6, and we'll press enter. Then we'll type in end, and we'll do a show IP interface brief, just to verify our work. So the parent interface does not have an IP address assigned, and the parent interface is up, which is really important if we want it to work. And then these two subinterfaces, one at 8.6 and one at 9.6, are representing or supporting the two VLANs, VLAN 1 and VLAN 2 respectively. And if we did a show IP route, that'll show us the details about the routing table, including that we are directly connected to VLAN 1 through gigabit Ethernet 1/0.1, and we're also directly connected to VLAN 2 with an IP address of 10.16.9.0 via gigabit Ethernet 1/0.2. Those are our two subinterfaces. So next, let's take a look at our topology to confirm what we've done, and then we'll test it from two clients, one sitting in VLAN 1 in Nevada, the other sitting in VLAN 2 in Nevada. All right, so let's confirm our work. On the switch, we configured 3/3 that goes to the router. We configured that as a trunk. On router 2, we created two subinterfaces, 1/0.1 and 1/0.2. We gave it the appropriate IP addresses for those respective VLANs. And then here on the switch, we have PC1 that's connected to a port on the switch that's associated with VLAN 1, and PC2 is connected on port 0/2, which is associated with VLAN 2. So let's go to these two PCs, PC1 and PC2. We'll verify that they both have default gateways that are correct, meaning .6 and .6 respectively, based on the VLAN they're on, and then we'll test the connectivity from PC1 over to PC2. So in the lab, we have tabs that we can open up for PC1 and PC2, and let's just verify the details. Now these are virtual PCs. To see the IP addresses and the default gateways, we can do a show IP, press enter, and this says that it's 10.16.8.10, which is appropriate for the VLAN 1 network, and its default gateway is 10.16.8.6. That's great. Let's check out PC2. So on PC2, we'll do a show IP, press enter, and its IP address is 10.16.9.10, and its default gateway is 10.16.9.6. So if we went back to PC1, and here on PC1, if we did a ping to 10.16.9.10, the default gateway should be used, which is the sub interface on router 2, who should then be able to route it all the way to PC2, and then PC2 would take the reverse path, sending the reply back to PC1. Let's press enter, and there we go. We have 5 out of 5 pings that were successful from PC1 to PC2. And this is all possible because router 2 now has 2 logical interfaces, one in each of the VLANs with associated IP addresses, and it can now route between those 2 IP networks. So thanks for joining me in this video and lab, and I'll see you in the next one. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.